Welcome back to the flipped classroom. Our topic today is solving equations with fractional exponents. Before we tackle our first problem, we definitely have to review the word reciprocal. Let me give you two examples. If I give you 2/3, we would say the reciprocal is 3/2. All we're doing is taking our fraction and flipping it. The top becomes the bottom, and the bottom becomes the top. One more example. If I gave you, -4, and I asked you to write its reciprocal, the first thing I would do is probably make it a fraction myself, so I would just put that over 1. Therefore, the reciprocal is going to be 1 over -4. Notice I'm not touching the signs, I'm just taking the fraction and simply flipping it. Question 1. 3x to the 3/2 equals 375. So again, this is called a fractional exponent because the exponent you see contains a fraction. So my first goal, of course, if I want to solve for x, is to get x by itself. So to get this term by itself, I'm just going to read it. It says 3 times x to the 3/2. So the opposite of multiplying would be to divide both sides by 3. And I'll rewrite x to the 3/2 equals 375 divided by 3, 125. Now, to get rid of that 3/2, we're going to raise both sides to the reciprocal. So, if I look at this fraction, 3/2, the reciprocal, of course, is 2/3, and whatever I do to one side, I want to make sure I do to the other side. Now, the whole point of raising it to the reciprocal is that you'll see I have a 2 on top and a 2 on the bottom, so they cancel, and a 3 on top and a 3 on the bottom, so they cancel. So I'm left with x to the first, or really just x. On this other side, we've talked about the previous day simplifying these in our heads. Remember, the root is on the bottom, so I am taking the cube root of 125. So what number 3 times makes 125? Well, that's 5. And then I'm going to raise it to that upper number, so I'm going to square it. My final answer is 25. So in Algebra 2, all of these equations we're going to quickly check. So I got 25 for an answer, so I'm going to put 25 in place of x. And remember, say the root in your head first. The square root of 25 is 5, and then raise it to that third power. So 5 cubed, and that's 125. So there, it does check. All right, let's try another one. -2x to the 3/4 equals -16. Again, this is a fractional exponent equation. The equation has an exponent that's a fraction. And my goal is to get this x term by itself. So again, if I read it, it says -2 times that quantity. So I'm going to simply divide both sides by -2. So I've got x to the 3/4 equals a negative over a negative is a positive 8. Now that I have my x by itself, I can simply raise both sides to the reciprocal of 3/4, which is 4/3. Whatever I do to the one, I'm doing to the other. Notice I'm not saying I'm multiplying both sides. I'm raising both sides. It's an exponent. And the whole point was the 3 on top and the 3 on bottom cancel, the 4 on top, the 4 on bottom cancel. So again, any number and its reciprocal cancel to 1. So I've got x equals, so in my head I'm saying I need the cubed root of 8. So what number 3 times is 8? Well, that's 2 raised to the 4th. And 2 to the 4th is 16. 2 times 2 times 2 times 2. So question 2, hopefully not that bad. Remember, your goal is to get the x by itself before you raise both sides to the reciprocal. Question 3. 2 quantity x plus 3 to the 5/2 equals 64. So one more time, my goal is to get this x by itself. I'm going to get rid of that 2 first, divide both sides by 2. So I've got my x plus 3 to the 5/2 equals 32. Now I've got this quantity as close to being by itself as I can, so I'm going to raise both sides to that reciprocal. The reciprocal of 5 over 2 is 2 over 5, and whatever I do to one side, do to the other. Those cancel, so I've got my x plus 3 equals roots on the bottom, so the 5th root of 32 is 2, and 2 squared is 4. Now, we're not done with that problem, you'll see, because I don't have x equals yet. I have x plus 3 equals 4, subtract my 3, and x equals 1. All right, we're not too far from being done. Here's question 4. Why don't you take it on your own, pause it, give it a whirl, and then play through my answer and see if you get the same thing. So here's my work. Hopefully you can follow. I subtracted 3 first to isolate this term. Then I said to get rid of a 1/3, the reciprocal would be 3 over 1. So I raised both sides to the 3 over 1. That kills those completely. So I've got my x plus 2. The first root of 4, of course, is just 4. So 4 cubed is 64. Lastly, subtracted 2, and hopefully you got 62. All right, in our next example, I want to try to solve this equation 2 different ways. In the first method will be with a fractional exponent. Now, you might be thinking I'm crazy because it doesn't actually look like a fractional exponent, but I'm going to make it into one. So to make negative 3 into a fraction, I'm just going to say it's negative 3 over 1. And that's perfectly legal. I can change any number into a fraction by putting it over 1. So now I have my fractional exponent, and I'll just raise both sides to the reciprocal. So again, I'm just flipping my fraction upside down, so I'm going to get 1 over negative 3. And whatever I do to one side, do to that other side. Okay, so the whole point is that the positive 1 cancel, negative 3 cancel, and I've got my x here. Now on this side, I've just got to be careful. I have a negative exponent. And we talked earlier in the week that negative exponents turn us into fractions. They move that term to the bottom. So I'm going to say it's 1 over 27, and that just gets rid of my negative. I still have the 1/3 power. One more step to go. I'm taking the cubed root, roots are on the bottom, cubed root of 27 is 3, and raising that to the first. So I get a final answer of 1 over 3 to the first, of course, is just 3. So that's one method to solve these equations. Again, if it wasn't a fractional exponent, I turned it into one. The second method is just to start from the beginning and tackle that negative exponent. Because it's negative, again, it's going to move me to the bottom, so I'm going to rewrite this as 1 over x cubed. So negative exponent shifts that term to the bottom. And it really is easier if you use fractions, so I'm going to turn 27 into a fraction by putting it over 1. At this point, I'm simply going to cross multiply. 1 times 1 and 27x cubed. Few more steps to go. I need to get x by itself, so I'm going to divide both sides by 27. And I've got x cubed equals 1 over 27. Last step here, to get rid of a cubed exponent, I could take its cubed root. If it were a square, I would take its square root. So I'm just going to take the cubed root of both sides, and the cube and cube root cancel, so I get my x. And I'm just, like I said, taking the cubed root of each of these numbers. Take it of the top and the bottom. Well, the cubed root of 1 is 1, because 1 times 1 times 1 is 1. And the cubed root of 27, well, what number 3 times makes 27? That's 3. 3 times 3 times 3. So you'll notice, either way I did it, I got the same answer in the end. It just is a personal preference on your part, whether you prefer the fractional exponents or flipping it from the beginning. All right, just 2 more to go. Number 6, very similar to the previous one we just did. So it's totally your choice if you want to go fractional exponent or rewrite it. But give it a whirl on your own, pause it, and check and see what I did. So I'm going to go fractional exponent, so I simply just put my negative 2 over 1, and the reciprocal of negative 2 over 1 is 1 over negative 2, and do that to both sides. Again, the whole point is those cancel, and I'm left with x. Because I have that negative exponent, I'm going to rewrite this as a fraction, 1 over 36 to the 1/2. And remember, the root is on the bottom. So I am taking the square root of 36. So I get 1 over 6, and then to the first is just 6. So hopefully an answer of 1/6. If you went that other method, where right off the bat you rewrote this as 1 over x squared equals 36, hopefully you got the same thing. And again, it's totally a personal preference, what you prefer to do to solve this problem. All right, last but not least, question 7. All right, negative 2x to the 4/3 minus 21 equals negative 53. Now remember, don't touch the fractional exponent until you get that x by itself. So move that 21 over, divide by your 2, and then play with the exponent. Again, try it on your own, and we'll see if we end up with the same thing. So I've got my negative 2x to the 4/3, add that 21 over, get a negative 32. Don't touch the exponent yet. Divide both sides by negative 2. X to the 4/3 should now be a positive 16. Fractional exponent, so its reciprocal is 3/4. Raise both sides. Those cancel. Remember, root first. The 4th root of 16. Well, what number 4 times multiplies to 16? That's 2, and then you're left with the 3rd. So hopefully you get x equals 8. Well, I hope you found the fractional exponents equations that weren't too difficult. Remember that word reciprocal, and we look forward to any questions you have, and we'll see you in class. Thanks again.